Um, Good morning. Uh, 3 weeks ago, Calvin invited me to talk about what we do here because we've been dropping off mysteriously for the past few months, on and off, here in UUCP. And we're not very sketchy people. We're just working. Yeah. Yeah. A bit of context. I'm Raphael Toledo again. Calvin asked me to also share my interest, why I got into this work. So it's a pretty bleak background. Most of the backgrounds that people have interest because of marine work is they've seen a lot of different beautiful things. But in my childhood, I've seen a lot of bad things. The first time I've seen a reef was it's a very destructed and very lots of algae, right? So very bleak. The most interesting thing that I saw was a double A battery floating in the front of my face. Yeah. So when I was grade school, I was given these books, science books, like all of us would. And what I saw was very different from my first experience in seeing a coral reef. Right, should be colorful, lots of fish. But that piqued my interest because why is it different in this book than what I saw? So from there on, I got really interested in science, studying everything about marine science. Yep. So a little bit background about what we do. So our project is entitled this. It's very long. Sorry. Yeah. But it's under a Pew Fellowship or a grant. It's from the America. Some of you might know it. So it's a pretty nice grant. So this is entitled Enhancing Local Capacity to Identify and Protect Climate Resilient Coral Reefs in Marine Protected Area Networks in the Central Philippines. So it describes itself, I think, pretty much. And it's very interesting because I didn't expect that I would talk with a full sermon and a full program. But I was reading this before this presentation, your responsive reading, and it pretty much sums up. It's very beautiful. It pretty much sums up what we're working towards and what we're working for. Yeah. Can I keep this after the talk? Yeah. Okay. It's very beautiful. Yeah. And even though we can also use this as a guide, just for reflection as I go through my slides. Yeah. So as a guide, I'll just explain the context of our project, the methods, some photos and activities that we've done, and emerging lessons that we've come up um, for this project. So, based on the sermon and the people here, you're very knowledgeable about the marine environment. Yes, yeah. Do you regularly do discussions about the marine environment? Yeah, talks. Yeah, yeah, uh, yeah. That's pretty cool. So I won't be talking mumblish stuff. Yeah. So you know corals, right? Corals are the beautiful things that are attached to the reef. You would know. Yeah. So these are these colorful structures attached to the reef, and they provide essentially animals or marine life habitats. So they provide structure, and in other words, in a more scientific term, complexity. Yeah. So marine life is also serving services to the communities, coastal communities mainly, right? So they provide fish, they provide tourism, livelihood, and they also provide protection against storm and wave damage. And it was also mentioned here. It's very beautiful. There was a word that I saw, bleaching, was mentioned here. And I think some of you know bleaching. So this would be a healthy coral, so full of color, right? So full of life. But when corals experience heat or stress in a prolonged time, they would bleach. So it's different from us. When we get stressed in the sun, we get tan, right? But it's different in corals; they get whiter, right? So it's pretty cool. That's because the living things inside them, they're also mutualistic or helping each other. They provide food for the corals, and if they're stressed, somehow they expel this and just panic altogether, right? And when the heat stress is prolonged over time, they die. So when this is prolonged and the corals don't recover, this complexity or structure or habitat for fish and other marine life is lost. So there's a whole lot less of stuff and living things going on. But doesn't mean that if corals are bleached, they are condemned to die. They can still recover if temperatures recover. So meaning temperatures that they are acclimated to or they are usually exposed to. So let's shift to a more depressing tone. Sorry. Uh, it was here, also mentioned here, yet the oceans are under threat from pollution, warming waters, overexploitation, and neglect. That's pretty nice. Globally, it's predicted by many scientists that by the mid-century, a lot of corals will die across the globe because of increasing water temperatures. But the next best thing that we can do is to identify and prioritize what reefs are most resilient or can resist climate change and heat stress. Right? So this is a map of Negros Island. We're here, Dumaguete. Yeah. And we can see that in this map, this represents heat stress or accumulating heat stress. And some parts of Negros Island are more exposed to more heat stress compared to this side of the island. No? So within the Negros Island, you also know about marine protected areas, right? So this is really the main essence of our project. So marine protected areas, their main goal really is to protect the fish and corals and all of the other life inside, and to really sustain that ecosystem services that people need. Right. However, if the heat stress continues to grow, how do we really know if Southern Negros, the MPAs in Southern Negros, are protecting resilient coral reefs? So that's the main question of our project, right? And one of the main problems in the Philippines and even maybe across the globe is we don't even know if our marine protected areas are situated in resilient coral reefs. So that's the big question. Are we really spending our funds properly, efficiently? Or should we turn to more resilient reefs, right? So that's the main question of our project. And it's really interesting because in this section, the oceans regulate our climate, nourish communities, and carry the rhythms of life. We are part of the sacred web of interdependence. That's pretty interesting. So even though most reefs are resilient, doesn't mean that the non-resilient reefs are thrown away, or balewala in the language, the Tagalog term, right? Because reefs are connected. They don't recognize municipalities, towns, borders. They're all connected. My boss, Dr. Rene Abisamis, he had this study of in Apo Island where he studied do the in the Tagalog term similia or the larvae of fish or the babies, do they travel to other parts of the Negros Island? So in the most simpler terms, are they all connected? And they found out that Apo Island was supplying all these larvae to Negros Island, Darwin, Shaton, Zambongita. That's pretty insane, no? Across a whole seascape. So yeah, the main problem is we don't have data and we don't know whether climate marine protected areas are resilient. And so we need site level data to inform this resilience, right? So one way to address this is using citizen science. So citizen science is a term that's used internationally, actually. So not just in the marine scene, but also in terrestrial. Birds, trees, mangroves. Here in this case, corals and fish. So we teach local communities, volunteers, to collect site-level data that can inform resilience. So these are some of the methods or the main methods that we use and train people. So they collect visually commercially important fish and indicator of reef health fish with size estimates to measure how many fish are within a marine protected area and how many. So, and another method is they also take pictures of reefs because in this picture, they can capture and collect whatever's in the reef that's attached to corals, seaweed, giant clams, and many other. So these are some of the examples. It's a shame that we actually sent our stuff to Manila last this week. I was supposed to show this to you, but we had to send it away. Yeah. So this is a what we call a slate or a data survey guide that citizen scientists use to collect this data, right? And here's some others. So butterfly fish are reef indicators of health for corals. So it's believed that the more corals and the types of corals, it's the same for butterfly fish because they're also similar or has a relationship. So we just this is just science stuff, yeah, nerd stuff, yeah. So we this data is encoded and processed via software that we use. Same for the fish. We also use a web app that also our boss made during the pandemic, right after the pandemic. So this data is passed down to the local communities so they can use this to inform their management, right? So not just resilience, but also what can they do to improve or inform their marine protected areas, right? But apart from the citizen science method, we also do supply them with more professional science methods because this is the usual way of collecting data. So it's kind of a safety net for citizen science. So we also survey these deeper areas, right? So we also survey fish species and we also take pictures of the reef bottom. So here's some examples of how the data looks like. So in this fish species data guide, my project cohort, Shang, she wasn't here. She's in Manila already. Sometimes this slate or survey guide fills up to the brim. And you have to have good handwriting if you want to be a fish scientist. Yeah. And then here's an example of a reef bottom photos. So we just analyze and collect data, whatever's in those photos. Yeah. And then here's an example too of what we also do. We also take pictures of coral juveniles, or the more informal term that we use, coral babies. So this coral right here is what you would see, the large corals, right? So this coral is the size estimately 1 centimeter. So 1 centimeter is your thumb, or the tip of your thumb, right? Yeah. So all this data is answering, are these MPAs resilient or not? So are there a lot of fish that can help the reef grow? Are there many corals, resilient corals that can self-sustain and be resilient against climate change? And for the coral juveniles, are marine protected areas supplied with coral babies or new growth in case these old corals will die? Yeah. So just we've done, so we've surveyed 40 sites across Negros Occidental and Oriental, and we've trained 70 citizen scientists to collect this data. Yeah. Very cool. And notably, all of these trained citizen scientists are local communities stakeholders. So they're what we call bantay dagats. Do you know the bantay dagats? Yeah. So they watch over marine protected areas, and many also in the local government that's involved. Yeah. So here are just some pictures of what we do. So this is Darwin. Some of you may have been to Darwin. So this is what they do. We've trained this person to collect the photo data. Here's a giant turtle, sea turtle. Yeah. Just chilling there. Then here's a reef in Zabongita, if you have been. So these are branching corals, and a lot of them are fish. Yeah. So there's a grouper right here. So other damselfish. Yeah. Yeah, there are also table corals there. And here's one in Shaton. So this is the one of the farthest municipalities. This is in Andulay, Siit, Barangay Siit. Yeah. So pretty nice photos. Huh? So the lessons that we've come up doing this work is they are really effective and efficient because you don't need a scuba certificate to collect this data with citizen science. You just need a passion for fish, knowledge for fish and corals, and really just a passion to protect your reef. And it's also good to update the ecological status of MPAs. So the project question is, are these MPAs resilient? But sometimes these MPAs, they don't even have updated data. So their past, like, or their most recent data was for before the pandemic. Yeah. So this also makes an easy way to update their ecological status. But it's also emerging that they need consistent practice. So just like us with our skills, they also need to practice it consistently. And MPA protection really is critical for maintaining fish and coral abundance, right? So we've observed and we've talked with people presenting the results, and we've shown and they've talked with us that the fish and corals have really declined after the pandemic, right? So it didn't just affect people, it also affected fish and corals, surprisingly. Yeah. And yeah, so the collaboration with different stakeholders is really special. You know? Mentioned here, we are part of this sacred web of interdependence. So even in ecology, fish, corals, plankton, whales are all connected. But even us people are also connected, and we depend on each other to protect these reefs, right? So we can't do it alone, especially academics and NGOs for technical assistance. So yeah, that's it. Really, that's just our work. So yeah. Any? Yeah.
Anybody have any questions?
Yeah, questions. Cool.
Yeah, who sponsors this?
Where does the money come from for?
The money comes from the Pew Charitable Trusts.
Oh, okay.
Yeah, so I think it's an American non-government organization.
Oh, so you'll be around for a while.
Yes. So our project duration is 3 years. We're at almost the end of our second year. Yeah.
Do you do any public presentations of your findings?
Yeah, we do. We always present our data publicly to the local stakeholders. And our real goal really is for the citizen scientists to present this data, not us.
So do you have like a meeting once a year where everybody gets together and you do
Yeah.
a summary of pictures of what you found? And,
Yep.
oh, okay.
So we report this data, not just like, hey, this is your data. We also try to find out what can we do with this data. So can this boost conservation policy at the local level or even at the national level?
Now, when you have these meetings, are they announced?
They be
These
announced?
yearly meetings are,
Yeah, yeah, we do announce them. We invite people.
and they're open to the public?
Depends, because we have to pay for their meals. Yeah, so we can try to open it to the public, and we can invite people who can really bring something to the table of discussion. Yeah.
Do you use AI and maybe you're training AI on your data?
So right now we're starting to use AI because we have a lot of data. I haven't shown it, but we do have a lot of picture data. And one of the real cool things about AI is it can fasten your, it can enhance or boost your workflow. Yeah.
Do you train AI on local fishes and species?
Right now we train them with coral pictures, not fish.
With corals?
Yeah, but there are people in our institute who use AI, I think, to identify fish. Yeah.
Okay, next question. Do you work with some tourists?
Tourists? What do you mean by tourists?
For an example, you have one camera and you have one person and one time. But the data that collected from the ocean,
Yep.
each tourist bring camera to the water and like, oh, here's a fish, here's coral, here's something.
Yeah.
If you will ask them and collect the data, well, you have data, you have location, you can analyze data.
Yep.
Do you work with it?
I mean, that is really the essence of citizen science. So non-professional scientists can collect scientific data, but our main goal is to train local communities. But there are other citizen science methods and people that have trained divers to collect data. One example is Coral National Beaching Watch. So people in the Philippines have created this sort of website where people can contribute pictures and observations of coral bleaching. So this is it's a form of citizen science because not all citizen scientists input those data. Yeah, so yeah.
So you need to promote your website and where people can share their own data and maybe receive thank you from the Philippine community.
Yeah, probably, yeah. I can forward you those websites if you want, just so you can explore the websites and learn for yourself.
Yeah, sure. I will add the link to the video under the video.
Sure, cool.
Okay. Some other questions?
Hello, Raphael. That's a lot of MPAs to dive with Negros.
Yeah.
So far, did you observe any bleaching?
Bleaching? Yes, sir. There was a global bleaching event in 2023, but the onset here in the Philippines was 2024. And we observed that if you go back to the... Yeah. So mainly the bleaching was observed here. And there was less bleaching here. So there's still some sort of level of bleaching here in Negros Oriental, but in Occidental side, there's a lot more bleaching occurring. Yeah. In
That was in 2024.
2024, yes.
And have they recovered now? After
That's
2
what
years?
we're trying to find out with our data. Yeah. Yep.
Do you happen to have any explanation why there's yellow in Bohol,
Yeah.
Negros?
So I'm pretty sure you know this, but there's a term that we use in oceanography, like an upwelling or a jet. So there's this water flowing in from Bohol that's pushing all this cool water and refreshing the temperature in Negros Oriental. So that's why there's this yellow or less level of temperature stress. But here in the Sulu side, in the Sulu Sea, actually, some scientists have termed it as a heat sink. So there's not much flow coming in or flow of cool water coming in the west side.
What is the difference in the degrees between hot and cold?
Oh, that's a nice question. So hot and cold would be based on what the corals are used to. So they have this term, what we call coral bleaching threshold. So it's a term that actually American organization uses, a government organization. Mainly when it reaches a certain threshold of what it's used to or the maximum temperature it's used to, it is assumed to be bleached. So that's hot. That's really hot. And corals are animals, so they have some form of resilience, so they can stand this heat stress, but only for a certain period of time. So when they exceed that certain period of time, it's very sure that they might die from bleaching or just bleach and might not recover. But if it goes back, similar to the slide here, wrong slide. So it can recover. So it comes back to the cold that we're referring to.
Oh, do you ever? I got well, it's actually a question for you and our speaker, because I'm a citizen scientist following coral reefs for 50 years now.
Yeah.
Anyway, one thing, I'm one of the few I've noticed that measures water visibility. When I visit a site, and I just have to guess water visibility. Do you ever measure water visibility while you're doing your study?
Mm-hmm. Water visibility.
I mean, how far you can see in the water.
Yeah, water visibility is one measure that can also help in minimizing bleaching incidences. So there's these papers that are reporting that their bleaching incidence was lower because their waters were turbid, or they have this layer of dirt or dust on top. So that minimizes the light stress or the heat stress for those corals. Yeah. Cool.
Um, before I got data from a NOAA marker buoy somewhere in Bohol Sea near
Okay.
near Camiguin,
Okay.
and it was, I think, an hourly data
Yeah.
for years,
Uh,
and somehow it's not there anymore.
oh. Well.
So, with regards to surface temperature, do you get data from
Yeah.
this NOAA?
We do collect data from the Coral Bleaching Watch product
Yes,
of
yes,
NOAA.
yes.
So they do. It's actually not a smart buoy. It's a satellite data
Yeah.
that they get the sea surface temperature from. But we also do have smart buoys situated in Darwin and in Lanhugan Island in Occidental.
And you place that one.
Yeah, we place that one. We just collect that data. It feeds us data since 2024. Yeah.
Yeah, that Coral Watch. Last time I knew, it's not in Bohol Sea anymore, but somewhere in the Visayan Sea.
Mm.
So like a
Yeah.
or like a collective.
I think you're referring to
The coral bleaching.
yeah, yeah.
Yes. Oh.
They had these virtual stations.
Yes.
And
Virtual stations,
before they were pixel based. So you can imagine in a map there's 5 kilometer square, and America has a satellite that records sea surface temperature data using the satellite. Yeah, in that scale. But they've updated their product. They've used now regional products, so a much larger scale. So you can this is actually for free. You can explore this on your own. Some of the scales for the Philippines is the whole Mindanao or Palawan and Central Luzon. That's one big scale. It's not the single pixel anymore, because they found out that it was the data was not very reliant in informing alerts. Yeah. Yes.
Yeah, I see some crown of thorns on the reef,
Yeah.
and so I just wondered if are crown of thorns a problem? I mean,
Yes.
are they in this area or?
In ecology, we have this term called invasive species.
They're invasive here.
They can be invasive if their populations rapidly increase and overgrow and overcome coral growth. But actually, crown of thorns are naturally occurring in the Indo-Pacific. But it just so happens that in the Philippines and actually many parts of the world, in the warmer temperatures, they've been overpopulating. One hypothesis is the increasing waters and also pollution, nutrients. Yeah.
Basically, Raphael, one for last thing.
Yeah.
So your project still covers this looming. I don't know if it's still looming.
Yeah.
This high potential El Nino this coming
Yeah.
year. So your project can still cover that.
Yes, we will end our project sometime around mid-year next year. So I hope it still covers the no. But the main important thing is we've been consistently collecting data on these sites. So the important thing is we have the pre El Nino data or the pre-disturbance data. So we'll be continuing to monitoring that with the locals. Yep. So,
Yeah, I just want to know, like in general, I don't know how vast data collection you've done, but how's the overall health of the marine ecosystem within the Negros Island?
how's the health? So far, what we've seen are this is the important thing about ecology. When you look at the big picture, you can see a single somehow idea or observation. So you can say na it's bad or it's good. If you look at the Negros Island in general, it has been decreasing the fish and corals. But one of the key things about our project is we also look at more deeply at a local scale. So we try to see what are the nuances in that idea. So okay, the corals and fish are decreasing overall, but are there some sites that have been maintained, are resilient, or are even increasing? Even the other sites are not. Yeah. So yeah, Generally, we have seen that many sites have been decreasing, but there are also sites that have maintained and even have surprisingly high corals and fish. Yeah.
Okay, thank you.
Yeah. Thank you. Cool.